talk about today. What is feedback loop? We are going to understand the difference between empirical and scientific approaches, how we can integrate the feedback loop in our development flow, and last but not least, collect and analyze data. Let's start with the feedback loop. So this is a definition that I found on Wikipedia. We can read together. Is feedback loops provide generic mechanisms for controlling the running, maintenance, and evolution of software and computing systems. That is quite interesting because are covering quite a lot of part inside the software development. So running, maintenance, and evolution. There are a lot of feedback loops in what we are used to do in some Scrum frameworks. So for instance, some Agile frameworks, sorry. So for instance, if you think about Scrum, we can see different feedback loops. For instance, in daily stand-up, so on a daily basis, our team is trying to understand where they are, if there are problems, and they're trying to share their experience that happened the day before. During the sprint retrospective, instead, we have our team that are analyzing a chunk of work that usually is as a sprint, and they are trying to share their experience, what didn't go pretty well, and what worked very well, and they're trying to improve from there, right? So then we have sprint review, that there is another type of loop that we have in Scrum, that usually is with the customer, where they are trying to give the business perspective to the team and try to understand how it works. Usually when we think about feedback loop, we have to talk also about the PDCA cycle. That is something that you can find quite easily when you read any book about Kaizen. PDCA cycle stands for Plan, Do, Check, Act. And this is, in my opinion, the root of all the feedback loops, because it's explaining quite simply how you should prepare your feedback loop. So usually when you try to create feedback loop inside your team, you have always to understand where you are at the moment. So you have to plan. So you have to gather some information, gather some metrics, understand where you really are, what you want to improve. And when you understand what you want to improve, you have to understand how to do that. And then you try to do that. So you say, okay, I would like to have less bugs in my software. In order to do that, maybe I would add more unit tests. So then you start to do this, and you start to add more unit tests. And at the end of your iteration, that could be one sprint, or it can be some time, like 1 month, whatever. Remember that it should be time boxed. You start to check what are the results of your loop. So you start to say, okay, I did like 50% of my of unit tests, and I have less bugs now. And we will see later why you should have less bugs adding unit tests. And then you act accordingly. Maybe you say, okay, yes, I have 50% less bugs in my software, but maybe it's not enough. It's not what I wanted to achieve. So probably what I tried to do, yes, I had a small improvement. I had my improvement that is 50% bug less, but I want to go closer to have 0% of bugs in my development. And in order to do that, you do again this loop. So you try to improve step by step, always gathering where you are, trying something in a short time, and then check the result of that, and then acting accordingly. You can see here that when you apply a feedback loop in the PDCA cycle, but any feedback loop, you usually start with a standard, you apply some modification of your standard, so how you usually work, you create a new standard, and then you iterate again. And that's let's say the basic of continuous improvement, right? So why feedback loop is very important in software development? And this is the question that moves us to the difference between empirical and scientific. So for instance, if I ask to a team in Japan and one in the US to generate water, they know for sure that with this formula they can create water, right? So the outcome of this experiment is well known by everybody, because if they apply this formula, they will have water. They will not have anything else. So what about software? Software is what we call empirical. So if you ask to produce a software in a team in Japan and a team in, I don't know, Europe, to create exactly the same software with exactly the same specification, you will have probably something that look similar, but they are not exactly the same. And why that? Because they take different technologies, they have different strategies, they have different frameworks that they can apply, agile frameworks that can apply if they use agile. So as you can understand, it's very important when you work with empirical situation to gather metrics, to analyze metrics, and start from there to improve what you have. Because otherwise, it will become impossible to reach the goal that your customer, in this case, or your company, asks you to achieve. Because when you work in empirical methodology, you don't have, this is the path that you have to follow, and for sure you will achieve a result. It will never happen. You have to find a way that works for your team to achieve that goal, and in order to do that, you have to be, let's say, more precise as possible, retrieving metrics and analyze them. So the keywords to work on software development, from my perspective, are having a lot of feedback, retrieving metrics, doing some trials, that is the spike, for instance, when we work in Scrum. Experiment. This is very important. For me, is the key for create great software. Small and constant. So if there are some feedback loop, for instance, for NASA, that are long 2 years, and for them is small. It's relative, Small is not a certain amount. I can't say that for your team you need 1 week or 2 weeks or 6 months. I don't know that. I have to understand how the team works. But you have to think always in a small chunk of work, because small is predictable. You can tweak your path and you tweak your way of working easily, because you did just a small improvement and you start to change it if needed, obviously. For instance, in my experience, there was I work in a large organization. We were in my department 110 people. The company was 1,300 people, and in my team, I started as lead developer, and then we started to work with Scrum, and we worked to create gambling games. Okay, so we were working to create a blackjack engine. Very, very simple, if you want. So we started to work with an iteration of 2 weeks, and everything was working pretty well. But in that case, what we were trying to achieve is creating a blackjack engine without inventing nothing new. So we know the rules of blackjack. We know what we have to do. We already had the graphics. So we have just to create the engine. Nice and easy. So there is an iteration. In 2 weeks, we show our result of the screen, and that's it. After a while, 6 months more or less, when we finished the blackjack engine, I was moved to another team, and we were working on something completely different. New team, so we don't know each other, and we were working to create a container for our games. The problem of the container was that this container should work with all the portals that the company owns, and we had different portals in different countries. And the problem was that it should be API agnostic. So we should create some APIs that were well designed in order to communicate with everyone in a nice and simple way. In that case, unfortunately, we didn't have all the specs. And we started with an iteration of 2 weeks. So we started to create our software, but we realized quite soon, after 2 sprints, that we weren't able to provide the value that the company was asking us. So what I suggested is, okay, let's take it small. So let's move to 1 week iteration. And in that case, we achieved exactly what the company was looking at. Mainly because every week we have some gates with the product owner that was saying, yes, you're doing right, and go ahead in that direction. Or if we, let's say, waste 1 sprint, it was like 4 days of work. Not much. So we can immediately tweak our 4 days of work and change something else. So when you're working in software, you have a lot of techniques that allow you to work with, to create feedback loop. Quite often developers start to say, oh yes, we have to work with tests, but they don't really know why. And it's something for me that is frustrating, because if you don't understand the big picture, you don't understand why you are doing something, you lose, let's say, the essence of creating good software. So for instance, we have several techniques that we can use, like automation testing, continuous integration, pair programming, I don't know, static analysis, QA testing, stand-up, sprint review, we're going to see that. And all of that has different feedback with a different time frame. So for instance, let's take a look at this. So automation testing, unit tests, TDD, BDD, these kind of things. So usually you have a feedback in seconds. And it's the first thing that usually your developer should have. But it's not only for saying, yes, we create tests just to see if the behaviors are working properly. Because as you know, sometimes the perspective of a developer is not correct. So they are creating tests and they are testing the wrong thing. And it could happen, you know, we're human, it's perfectly acceptable. But the thing is, usually when I speak with junior developers or people that are not used to apply tests to their code, I always said, remember that the test is not only for testing purpose, just to see if the behavior or the code that you have written is working properly. It's also for design purpose, so when you want to design your solution in a better way, because test is helping you to create that, in particular if you work with PDD. And also because automation testing, it provides you an immediate feedback. So you write your test, you implement the code, you prove that the test is passing right now, and in a few seconds you have immediately a response. You don't have to wait the end of the sprint to see if it's working properly. You don't have to wait the manual QA that check your code, and you don't have to deploy the code in the production environment or wherever. So you have an immediate feedback of what you are doing. And the same for continuous integration, when you try to merge your code all together and you are working in a team, or pair programming. Then we have different feedback loops that you can have a feedback, so a response after a few minutes, like code reviews. This is very important. We will see in a minute what you can do. Static analysis is another thing that often is not, let's say, took in consideration by companies. From my perspective as a solution architect, I used to set immediately the static analysis in all the projects that my team are working on, if there are multiple projects or one project, mainly because I can understand how healthy is the project, and also because I can't handle 100 people alone. And I have to trust my developers. And the best thing that allow me to understand if the project is going in the right direction technically is static analysis. Then we have QA testing that usually requires hours. So usually a manual QA starts to test new features of the project and do a regression test and stuff like that. Every time that we implement a new feature, we fix a bug, but it takes time, a lot of time. So you can understand that we are moving from seconds, immediate feedback, to hours. And now we have something different. So we have a feedback in days, like emergent design, or the stand-up, daily stand-up, or we have different feedbacks that we have in every week. You can understand that there is a wide range of techniques that you can have, and you can have all together potentially if you are well organized. It's not a big deal. The most important thing is understanding where to use these different techniques and what you should achieve with them. So let's take a look to the main goal of this. So when we apply all these techniques, or some of them, we are aiming on having a better code quality. We're checking the code standards, so in each team or in each company you should have some code standards that allow you to switch easily between different projects, different code bases. This is very important, catch bugs early. As you know, if you catch the bug when you are in production time, so when you are working directly on the code, the time to fix it is ridiculous, so it's a few minutes, maybe 1 hour. worst case scenario. But if you catch the bug in production, usually it takes days to understand what's going on. Mainly because it's not because you have weak developers or the developers are not good enough. The main problem is I'm working on a feature. I work, I don't know, 8 hours on that feature. So now I'm mastering that feature. I produced that feature, was tested, passed all the tests, passed all the regression tests, was merging the code, was delivering production, and then suddenly there is a bug. Okay, so meanwhile, before we arrive to all this step, if you don't have, let's say, continuous deployment, usually it takes, I don't know, a month before you see your code in production. So in a month time, the developer started to work in other, I don't know, 10 features, 2 features, 3 features, I don't know. So it's tough to remember exactly what you were implementing at that moment. And it's not because it's stupid or it's weak or it's not a good developer. It's because usually when you start working something else, your mind completely, I don't know, trash what you have thought for that particular feature and start to think of something else. And it's perfectly fine. So that's why we have tests and we have all these feedbacks. Obviously, the cost of catching bug later on in the process is way higher than catching them at the beginning. We want better performances on our code. We want to have a high maintainability. We want to meet the requirements of our customer. We want to create value for our customer. That is often something that developers forget about. Create value is the main goal of creating a product. We are not writing features for ourselves. We are not writing features for the company itself. We are creating value for the customers for the users of our customers. That's very important. Share knowledge within the team. That's another thing that I value a lot. And at the end of the day, also to improve ourselves as much as possible. This is what I was saying. So as you can see, this is a normal graph that you can see in any agile book. So if you catch the bug at the beginning of your development phase, as you can see, the time to fix it is very low, and so the cost. At unit test is slightly higher, but we said that the feedback loop here is in seconds. And then QA testing usually is in hours, so it means that meanwhile your developer is doing something else. In production, it could be even worse. It could take, I don't know, 1 year before you catch that bug, and weeks before you fix it. So, how to integrate feedback loop inside your development flow? So let's talk about automation testing, for instance. So this one is a feedback frequency that is in seconds. And if you think about TDD, that is not a technique that is used everywhere. And again, I'm not saying you need for sure implementing TDD inside your team, otherwise it's not going to work. What I'm saying is, if you need to catch bugs earlier, improve your code quality and maintainability, probably this technique is something that you should look at. You can use unit testing, but probably you are achieving another purpose, because with TDD, as you can see, we are creating again a feedback loop. So you started with creating a test that is failing, and then you make the code in order to pass this test, but it doesn't mean that it's finished, because usually if you master TDD, usually the first thing that you should do is just create a function or a method that return a way to pass the test. And then you start to refactor. That is the most important part of TDD. This is the most important part of TDD, because when you start to refactor, you start to improve to achieve exactly this. So code quality and maintainability. And it's very important at the end of the day. We have continuous integration. Continuous integration for me is a mandatory thing for any project. And it's the first thing that I use usually during Sprint Zero. There are a couple of things that I used to do with my team. So the first thing is creating all the automation build and creating all the pipeline to create to have the automation for testing, for releasing, for continuous integration. We set up all the deployment tools. It depends which team I'm working with, but sometimes it's Puppet, sometimes it's Bamboo, it depends. Usually I work also strictly with my AWS engineers in order to understand how to architect at the beginning the project. But continuous integration is one thing that I recommend to everyone, because having automation in place as first thing will save you completely your life during the project development. Because usually this one takes probably 1 day, 2 days. It depends on how often or how much knowledge you have on this, on continuous integration. But usually this, then it will provide you a predictable artifact. That is the most important thing, because you can't rely, and I saw quite often in 2016, you can't rely to provide to your customer a build made by your computer or the computer of your developers. It doesn't make any sense. It's not predictable. If that developer installs something on his computer that is completely screw up the continuous integration, you can't provide anything that is useful, and you can't understand why it's happening. If you have something that is company-wise predictable, and you just click a button and boom, you have the artifact, or you deploy in a particular environment. This is predictable. This is exactly what your customer is doing, and it gives you a lot of confidence on what you are writing, because you are sure that the moment that it arrives in Git and arrives in that environment is exactly what the customer wants. With 2 people in rotation at the beginning, and then when you see that there is value on them, on it, you start to increase. But you can't have like 8 hours per programming, because doing right, it means that after 1 hour it's like 6 hours of work. Trust me, it's very, very tough. Code reviews. This is another practice that, in my opinion, is very useful for knowledge sharing, but not only for that, because with code reviews, you can often catch some performance issues on the code of your colleagues, and it's something that for me is mandatory also for sharing. For the improve the code quality. One thing that you have to bear in mind with code reviews is just one thing. Often it could happen, in particular if you have a strong hierarchy inside the team, that only lead developers are doing the code reviews. This is something that you should, I can't say avoid, but you should encourage also mid or junior developers to take a look at this. Because usually when, for instance, I have a team that is a mix between junior, mid, and senior developers, I always encourage to have one junior and one senior or mid developer that is checking the pull request. Mainly because in that case, you can increase their knowledge. The junior developer can understand why the senior, the mid developer is saying, oh, is asking for a particular thing inside the code review. And also encourage the team to ask questions inside the code reviews. It's not just pointing the finger against some code. It's just improving what you have, because the code is shared it's made by a developer, but it's shared across the team. So it's a collective effort. It's not just a developer effort. So it's very important that everyone feels part of that code, feels that code is owned by the team. This is what I was suggesting. It's very important, in particular for architects, but also for, in my opinion, for a Scrum Master or people that want to understand more without being too technical what's going on inside the team. So this is, for instance, one screenshot that I take from a tool that is called Plato. It's a JavaScript tool, but you can have many of other tools that are providing this information. So basically what is happening here is giving you the average maintainability value that is from 0 to 100 of the code. And you can understand from here each single class or each single file, which is the maintainability quality of the code. So you can understand immediately from here if you have some spike, down or up, it depends, which is the most, let's say, weak part of your product, or the most strong one. This is very important because from few graphs you can immediately understand where you would have some tech debt, also without asking to the developers. And in particular, if you are working in a consultancy firm, that you have different projects you have to take care. This thing allows you to understand if the the code that is written by the developers is well thought or not. There are a lot of metrics that you can gather from here. These are just free, but I take just maintainability here, and how many lines of code you can have on different files. I believe that this one, in particular for tech leads, for lead developers that are jumping from one team to another one, is a lifesaver. Because you can immediately in a few minutes understand what's going on. You can apply usually when you integrate, when you configure the continuous integration. So every time that the developer is merging the code in the develop branch, you run this test. You run this analysis, and you can understand immediately what's going on. Or before the developer start to release at the end of the sprint in staging, for instance, in staging environment, you can run this test. And this test will understand immediately if next sprint you have to spend some time on tech debt and solving some problems or not. Is, in my opinion, very interesting. Another thing, I added this slide because as architect for me it's very important to suggest the best way to design a product. So I started to work in this industry 13 years ago. So I can't say a long time ago, but 14 years ago, when Agile, in particular in Italy, it didn't exist at all. So when I started to work, usually I started to architect all the projects, also as a developer. Architect all the projects since the beginning, say, okay, I have to create this cluster that does this, and the other cluster that does that, and so on. At the end of the day, I started to create these giant UML diagrams. And after a month, I can trash them because they weren't reflecting my system. And what I discovered slowly by slowly, working and gaining more experience in this industry, is important to decouple the design of a system with the architecture of a system. Usually, the architecture is just some let's say some concept, high-level concept that are driving the whole system. So you're saying, okay, I'm working with reactive programming or functional programming, and inside there we want to use these patterns in order to implement the whole system, and that's it. The design should be tackled sprint by sprint by the team. What I usually do as architect is just overseeing the design. But also if the design is not my favorite one, I try to leave the experience to the developers to understand why they should implement it in one way. And maybe I learn something new, because quite often happens that the guys are implementing a particular piece of work in a different way compared to what I was thinking. And for a certain degree, it's working better than what I thought. And it's very important that you empower the team when they are taking decisions, because otherwise you transform the developers in monkey coders, and it's not what they want. They are people that have usually a brilliant brain, and they want to use it and suggest, and in order to feel the ownership of a project, they need to take decisions. They need to be important in the project, because otherwise they will never perform properly. So in this case, for instance, emergent design, you have usually you start to do do design of a solution at the beginning of a sprint. So when you say, okay, we have five features to implement or 3 features to implement, how do we integrate our code in the existing code base? This is what you usually do. And sometimes the guys are asking me, can you join at the beginning of the sprint and see if we are saying a lot of rubbish or good work what we have in mind. And usually my, let's say my way to work in this, with this team is just saying, okay guys, show me what you have. And then I try to ask questions more than say, yes, you have to do this or you have to do that. Because if they arrive to the final goal, they will, that particular thing will become, or that particular technique, or that particular design pattern, they will start to own that thing, and they start to understand why they have to do that. If I start to say, you have to do this, they will never learn. They know that there is one person, the architect in this case, that is providing answers, or is providing the way how to do that. It's not going to work in this case. The guys, the developers, they have to arrive to a decent thing, and sometimes they have to make mistakes. Also, if it's against the, let's say, the final goal of the company to create value, they need to make mistakes because they learn from them. So we are arriving to the last part of the talk about collecting and analyze data. So usually this is the classic thing that you can use when you work with Scrum. For instance, you can understand the velocity of your team between different iterations. You can see that after a few sprints, you can have let's say more or less a constant number of story points that you are delivering. Like here, obviously, longer is the project and more stable becomes this diagram. But yeah, quite often you can find a lot of the information how the project is going goes from this kind of chart. So it's very important that you keep that you ask the team to maintain a decent velocity chart for you. There is other tools that, for instance, we are using Atlassian in my company. It's very powerful because with all the if you use properly and you use Jira, Bamboo, and all the Atlassian tools, you can create different charts like this one. For instance, I take a screenshot of our daily bug update, and I can see how it's working. So I can see that basically here we didn't do much test because probably here we were at the beginning of the development, so there wasn't a lot of things to test. And then we start to raise bugs, so manual QA and our tests start to see there were some bugs, and then we start to work, and now we are basically working together with manual QA, and we can immediately see that here basically there was a big gap. So basically probably it means that we work more on features, and then we start to catch up with all the bugs. And I can understand immediately if the guys are creating more problems than solving them, and I can address them asking and talking with the team of where the problem is. These kind of things are the things that change dramatically the final outcome of the project, because you can understand that you can fix the problem during the development and not at the end when you are delivering the result to the customer. And then we have different things. We divide it basically between front-end bugs, back-end bugs, and we can understand which area the bugs are raising up, and we can understand these kind of things that are very important. Because if, for instance, you can, I don't know, you have different area inside the backend team, and I don't know, this green here is, let's say, a very important part of your software, and you see that the bugs are raising up compared to the others. Probably you need to put, I don't know, a lead developer there, or you need to understand what's going on there, because this kind of charts is very important for anyone, in particular if you are a Scrum Master or Product Owner, because you can start to address problems immediately. You are collecting that data and you are acting based on the feedback that you have from your tools, and you don't have to ask anyone anything. You just need to start at the beginning of the project these tools. This one we already discussed about that. This is a bigger picture, but as you can see here we have different files, and I can see which is the maneuverability of each file. Sometimes, on purpose, the developer can create some tech debt in specific classes, but maybe there is a valid reason to do that. Tech debt, yeah, it could happen, and usually it happens quite often, but there are some critical tech debt and some other that, yeah, you can survive with it. This is another interesting one from Git. I didn't see many people checking this information, but if you work with Git, you have a lot of information on how often the development team is pushing the code inside Git, and this is very important because, for instance, one metric that you can find from one information that you can find from this matrix is the following one. Let's say that you have a team that is, I don't know, handling 10 stories per sprint. But at the end of the sprint, quite often they didn't release all the stories. From these metrics, you can understand if the story is too big, Because if they release or they push the code instead of every day, every 3-4 days, probably the story is too big. So you can immediately say, okay, so the guys are not pushing the code often, and if they don't push the code often, it means that they will spend more time on fixing bugs or other issues when they merge the code with other branches. So probably from here you can understand immediately, okay, let's check the story size. Let's see if we can split them down, and you can adjust the velocity. And these kind of things are very useful, and you can't find just ask the developer, because sometimes the developer has the concept that, oh, 3 days stories is fine. It's not bad. You are delivering every 3 days a new feature. It's good. But as technical person or Scrum Master or product owner, you need to understand if what they are working, that the final aim of the story is too big or not. Because otherwise, you risk to have, let's say, too much work to catch up and not delivering the value that you were looking for. So these metrics are very, very important. Also, you can have, for instance, here you can see that there is a single developer with all the pushing, all the, let's say, the code pushed in a particular branch or inside Git. It's very important also to understand the performances, and maybe if there is a developer like this one that is not delivering much, what does it mean? Is it, I don't know, a junior developer? Is he on holiday? Or there are any problem? From just this thing, you can understand if you have a problem inside your team, and then you have to understand how to address that. But at least you can understand without being let's say, a psychologist or whatever. You just need to check the data. This is my favorite one, honestly. You can create also in Jira. If you are familiar with Kanban, it's very famous. It's cumulative diagram. And from here, it's very cool because you can understand how your project is going, or if you finish a project, you can analyze where the bottlenecks are. Because, so basically each color represents a phase of your development. So you have the purple one is deployed, and the green one is ready for approval. The yellow one is in testing, the red one is in progress, and no, sorry, the first one was this one. Is the blue one deployed, and the purple one is ready to start. So basically here there is the analysis phase, and as you can see here, backlog is increasing. So it means that the customer or the company added more stories to your backlog. And you can immediately spot it because there is this gap. So then the progress start to go quite well, and then drop off. So what's happening here? Probably new person inside your team, or someone that went on holiday. Who knows? But you can understand these kind of things, and you can have decent metrics to share with your management. Just looking at this, you don't have to do any effort. You don't have to collect any information. These kind of graphs, or these kind of diagrams, are retrievable by a lot of softwares. So these kind of things are the lifesaver at the end. And when you finish a project, if you have something like that, it will allow you to understand where the bottlenecks were and how to potentially improve for the next project the techniques inside your team. I wrote also an article that you can find in the Scrum Alliance website. Go a little bit more in depth about each single technique. I think if you are interested in that, you can just search for the power of feedback loops. I think it's an interesting topic, and often we forget about that. But for me, it's mandatory to have always in mind, because it helps me every day my daily job. So just to wrap up, 1 minute, perfect. So when you think about the feedback loop, you have to do it often. So more feedback loops will allow your project to hit your user customers' goals. Make it short. Keep the iteration as short as possible in order to close more feedback loops as possible. Think always about continuous improvement. If you are interested about that, I would suggest you to read some books on Kaizen, because Kaizen is basically, it means in Japanese continuous improvement. And there are a lot of shift of mindset and that could help you to improve the quality of your team, the quality of your life, because it could be applied on your, let's say, daily life and personal life, or let's say technical life. It's up to you. For me, it was a big game changer in my life. Measurable. So always collect data and metrics and try to analyze them. Because without metrics, you can't see where the improvement is and if there is a real improvement. And that's really it. I don't know if you have any question for me. Yeah.
I have a couple of that.
Yeah.
So just in regards to the static analysis that you
Yes.
talked about with the looking at the maintainability of the code.
Yes.
What was that program called?
Plato. But there are several of them. You can just search for static analysis and you can in the language that your team is working with.
Cool. And also, we're discussing looking at the code, and you've got some graphs that look at, say, finding bugs in front end compared to back end.
Yeah.
Do you find that this sort of granular analysis can ever sort of contribute to a negative blame culture? And if so, how do you combat that?
Yeah, it could lead to a blame culture, but it depends how you used to run your team. Personally, I'm a strong believer on flat hierarchy, so I value also the feedback of junior developers. So if there is a problem, we solve together. If we succeed, we win together. If we fail, we fail together. There isn't for me any. I think that it depends how strong is the hierarchy concept is. If it's so strong, probably it's better not to share this information, but to use them just for your own use. But I prefer to have an honest feedback with everyone, because in that case, it's the only way to improve the developers. We are not perfect, and we can become a better person just analyzing what we are doing and improving ourselves. There aren't any other way to do that. And if you don't have metrics, I don't know how to do that. You're welcome. Any other questions? Okay.
Can you make the slides available, please?
Sorry?
Can you make the slides available?
Yeah, of course. Yeah, I will do that. I will share on Twitter. Cool. Anything else? Cool. So thank you very much, guys, and have a nice conference.